Número 1 para los olvidadizos.
All right, hello everybody, and welcome to this first time series or bash scripting that I'm making. This episode is meant to be a first in a series of 10 that I'm planning to do. And of course, if the reception is good enough, then I'll eventually consider expanding it even further, as long as new and more interesting things keep popping up. But for this tutorial in particular, let me open what I have prepared here, my terminal. So I have this script called stats that upon looking at the file itself, immediately you can tell that this is going to be a very short program. It's literally just that long, barely had to scroll down using Nano, my preferred text editing software for now. For now, I know some of the comments are gonna recommend I use Vim, but but anyways, um, I made this program, and will be the easiest one. And the other programs are going to keep getting progressively harder, but this one right here is the easiest one, and it particularly solves the problem of displaying certain types of information to you, the user, via the terminal, specifically information that you might often need to access. Like, for example, you could think of the date, the time, perhaps even the temperature. And these are all things which this tiny bash script actually displays to a terminal session. So by the end of this, you'll be able to, like I said, display that type of information. And I might add that, of course, this is not a program that ends here, since it is literally just essentially catting, you could say, or, in this case, it's echoing. For those who don't know what cat is, I will explain it some later. It probably in another program, but it's just echoing output, specific system output to the terminal, and you can make display any other output that you think that might be very useful by giving the argument. So again, who is this for? When should you use this program or not? If you need some sort of type of data, I already mentioned the time, the date, and temperature, but you could of course also display systemic information like your disk or drive space, in case you don't want to navigate to a certain directory to look at how many files or the directories that you have in there. It could also just print it out. Of course, I do have a program that is sort of dedicated towards that end, but that's going to come in another episode. So for now, I'll be showcasing how the software works. So the script works. I'm going to open a new tab. All right, finish loading. Got my user, and I already got all my scripts in that script directory. So what I was going to add from the beginning was that, for example, let's say that I don't know how to use this program, and coincidentally enough, I actually don't know how I programmed it to run, so I don't even know what the arguments are, because these are programs that fundamentally run with parameters to do different things from the terminal. So if we go back to the nano file, the text file right here, there's the entire structure is just structured with if and else statements based on the first argument that you feed the program. You could work with multiple arguments, but I find it easier to just base all of your performance and tasks. Everything is based on the first argument, and then you just give it a prompt, which is essentially going to take your input and to just put it into variables before doing something. But that's again for future programs. That is not something that is going to be reviewed in this one. So if you go down here and you feed into your argument, which is your right here, you have your $1, if it is equal to up here, help, or rather down here, if it is equal to help, then it's going to give you usage data, which is exactly what I'm going to do. So it's called stats. Let's give it the help option. All right. So this is how you use the software. So simply put, you just put stats, and the way I programmed it with no argument is that it's going to display the date and the time. It's as simple as that. In case I ever need to know the date and the time for some reason, for homeworks, for sending emails, writing anything that needs the date on it, bam, that's how I get it. Now, if I feeded the argument t, again, it's just based on the first positional argument, then it's going to append the temperature in Fahrenheit, of course. So now I'm going to showcase the program running some more. So let's go simply stats and see what it outputs. So here, it gives me good morning, and then it gives me my username. Here are today's stats, and then bam, it just concatenates, Sunday, February 1st, 2:33 a.m. with 36 seconds, very, very precise. If I didn't want it to display that, I could simply just go back into the file and right here, where you see the echo and the date, and I could just take the percentage capital S option out of there, and it wouldn't display the seconds, right? So, and then of course you have your year, which is 20 space comma space 2026. So that is what fundamentally happens if you don't feed it any arguments. Now, if I feed argument t, as I said earlier, I'm gonna do the same thing. It's gonna lag a little bit because it's fetching the temperature, and it says that it's I don't know why it says plus 10 degrees Fahrenheit, but bear with me. Probably because temperature could drop below it, be in the negatives, but thankfully right now it's in the positive 10s, which is still very, very close. But anyways, the way that is happening is, or fundamentally, if I explain sort of like the structure of everything, if we start at the beginning, of course, this is a bash program, so you have to include this first line. Then, to fetch the actual time, you have to use the date function, which is assigned to a variable called hour. Similarly, whether it's AM or PM is assigned to another variable, IM PM, with the same date, and of course, it's using those parameters, which you would simply have to know. Day or night starts being undefined. I could have simply left it as, an empty string, but just to be clear, it starts as undefined because within these next set of if-else statements, it actually determines, it does a calculation based on the time and if it's AM or PM, and it gives you a custom message. So it would either give you good morning, good afternoon, or good evening, depending on what time of the day it is, based on those two conditions here. Now, as I was saying, if you don't feed it any arguments, in the case of this first positional argument, where it says if $1 is not equal to help, what that essentially means is that it's going to give you the date and the time in the way that I programmed it every single time, as long as you're not asking for the help option, right? It's going to give you the day, the date and the time, and it's going to echo it back to the terminal. Now, when you use the T option, again, because you didn't give it the help option, it's still going to, once again, print the date and the time first, but it's simply, essentially what I like to call it, it concatenates the temperature right here, where it says $wget. Well, wget is the bash equivalent of, when you download a resources off of a website, whether it be a file, or in this case, you're getting direct information off of a website. So when you have the negative QO over here, actually that's not an O, that's a 0 now that I look more closely at it. That simply means quiet output mode. So quiet mode simply means that it's not going to give you a long list of output. Like Bash traditionally likes to give you lots of outputs depending on what you're running, but in here with the quiet option or the quiet mode, it's only going to display exactly what you're asking for the most part. And then the output mode ensures that wget is actually not downloading a file, which is what it's usually used for. It's going to instead output it where to the $ terminal, which is what echo $ and this entire string expression. Now, you might be wondering what wttr.in question mark and then the rest is. That's simply a place. It's like a web address, right? It's just a URL where it's getting the temperature from, right? And it's also asking for a specific format. Again, this is not something endemic to Bash. This is just how that particular website works, which I did have to look it up to actually get the correct information in the correct format that I wanted it, instead of a bunch of jargon that I didn't need for my use cases. So, it's pretty much the entire program. However, I do have to go over some things. For example, some things to note before finishing this tutorial, very, very short tutorial, might I say. It's that, let's say up here, I was talking about the date function earlier, where it's being assigned, the value that it returns is being assigned to the hour and the AM PM variables. Well, for example, let's say that I don't know what the heck is plus percentage capital H or percentage lowercase p, right? So let's say I literally don't know what it is. Well, let's go back to my other tab, and you can do the exact same thing that I did with my stats help option. You can simply put date function, right, or the date script, whatever it may be to bash, and then ask for the help option. And then here's the magic. It gives you an enormous list of possible the options that you can feed into it, the parameters essentially. So every single one of those percentages that you feed to it, it's going to give you a specific output, which literally tells you right here to the right next to each one. So this can be incredibly useful. Just simply the help option. Anytime that you don't know how to do something with some sort of bash script or anything that is being run on the terminal, most likely it has a help option. Sometimes it might not, for the most part. The general rule is that the help option will be there to actually help you. And then if you read down here, it probably also tells you like how do you actually use software instead of just giving it the options. Some things to note. Now, another thing that might be worthy of pointing out is, for example, let's go scroll back down here with this elif and if expression. So for example, let's say, well, in this case specifically, negative GE, and then down here, or rather up here, we also had negative LE. It's an option when putting in a comparison inside of an if statement. So what that's doing is negative LE is essentially saying is the hour, the current hour that the date function gives you, is it less than 12 is what LE would be. And of course, GE would mean is it greater than 17 or greater than 12. And 17 would be, like the time where it's usually considered the evening, as long as it being AM, PM for the conditions. That's all I have to review for today. Like I said, this is a very, very fundamentally short program on purpose, because the ones that will be coming after it, they're going to keep getting incrementally longer and more complex. So I just wanted to start with something simple just to get something out. You can expect more tutorials as time goes on, but for now, if you have any suggestions, any changes that you might want to make, any suggestions for things to even add, right? Any added functionality via more arguments, more parameters, maybe even a restructuring of how the program works instead of using arguments. Perhaps I could have used a prompt, but again, if there's any suggestions of any sort, you can leave it down in the comments below, and I'll see you on the next one. And consider subscribing too, because there's going to be more to come. Bye bye. I forgot to mention something incredibly important earlier, editor's note. I will add that the way that this and all subsequent bash scripts will work is that you actually cannot simply execute them by stating their names in the terminal, and they're simply going to work. Of course, bash has no way of actually locating those scripts whatsoever, because if it's able to locate any scripts that you might be using already, like say cd or cat or make dir, remove, anything like that, right? The reason that it's working is because those scripts, which they come bundled with Linux, whatever Linux distro you have, they already come bundled, of course, with the operating system, but also they're already essentially in Bash's path, and I will show you exactly how that works. So first of all, let's go back to my home, which is you can get to by using cd and then the tilde. And right now I'm in my home directory. So what I'll do is, in the home directory, you can actually find hidden files which are typically not visible to you unless you ls, oh my bad there, la instead, it's ls with the -a option for all. And here is where you can actually see hidden files, which are denoted by a single dot. In my case, you have some red and white text, and there's also the dark green, but in this case, with my colors that I selected for my terminal, the white text entries are actual files, and the red ones are directories. And then these dark green ones are temporary files that are open in, say, the nano editors. that you're using. So the file that we're looking for all of these is the .bashrc file. So that's nano.bashrc, and you have to include dot because it's a part of the file name as well. All right, so this is the .bashrc file, which is responsible for essentially being able to find where your scripts are. So I'm not entirely knowledgeable on all this stuff that's up here. I'm pretty sure it's, again, you're given references to specific files. So you right here you have the $shell /bin/sh, for example. So it's just where this is where you write down your references for where you want your scripts to be found. So in my case, I put all my scripts down here, scrolling all the way down, all the way at the bottom, all the way right here. So right here, I left a note for myself saying that these are my own scripts, right? And the way that I structured, I won't be showing what the other 9 programs that I've yet to make a video on are, but for ours specifically, called stats, down in the second option over here, with the way that you have to do it is you have to set an alias. So what is an alias? It's essentially a keyword that represents that, oh, I'm trying to open this particular bash script, and coincidentally, we named the script file as well, stats, right here. So the way this is working is adding an alias called stats. That's what the program name will be called or executed in the terminal. And then you simply just have to give it a file system reference to it. So in my case, it's in $scripts directory, which is literally just a reference to this variable over here, including the file path to it in my scripts folder. And the script itself is called stats. There's no extension. It's not .txt or .sh or anything. It's simply a file called stats, and that's all that it is. And once you do this, and once you save, in the case that you had your terminal session open, you would have to either close or open a new tab, because it's like at that point in time, you edit and you save the file, but Bash is already loaded. So it has to reload to actually reread that new reference that you added to that alias. Or something else you could simply do is open a new, or if you already have an open tab and you don't want to open a new tab for some reason, you could also simply exec what? You exec bash. Pretty sure that's the command. Someone correct me if I'm wrong, but then once you do that, it's going to reload the reference, and it should be able to find your program or your script. So in this case, stats, bam. I mean, mine was already working because it was already set in such a way, but it's just a very important reminder that this is not going to work with custom aliases if you do not edit your bash rc file. So you have to do that, or more easily, I presume, if you wanted to work right off the bat, you could probably just put it in this bins /bin/bash file where all the other scripts are. But that tends to get messy, and I recommend putting everything in a custom script somewhere in your file system, wherever you prefer. It doesn't really matter, but I don't recommend putting any scripts that you make along with bashes, because it's better to keep them separate so that you know which scripts you make in case you want to go ahead and make some changes later on. It's a lot easier to find. So I'm not entirely sure where those scripts are saved, so I will not be showing them in this video, but it's something to note.